Now, to find the mean, okay, you have your function, which is your distribution function, okay? Sorry, which is, no. If f of x denotes the function of the random variable, okay, then the expected value, or what's known as the mean, okay, so this is three ways of referring to the same thing. You've got mu, or expected value of the function, or the mean of the function there, is the integral of that function multiplied by p of x times d of x. And so, if my function is simply x, then equation 1, which is this one here, gives the expected value, also known as the mean value. Okay, so you take xpx dx, and you integrate that between minus infinity and infinity, and you get your mean value. Okay, you were probably expecting, you add them all up and you divide them by the number of samples you've got. Well, that's the case when you've got discrete functions. Okay, here we're talking about a continuous function, and so you have to use integration instead of a sum. If f of x is x squared, then we get the mean value, the mean square value. Okay, so you essentially put x squared into that integral and integrate between minus infinity and infinity, and you get your mean square value. And RMS, root mean square, often crops up when dealing with randomization, and that's simply the square root of your mean square. Okay, so you take the square root of this term, which is there, and you get your root mean square. Variance, okay, of x, denoted as sigma x squared, is defined as the mean square value of x about the mean. Okay, and so to get it, you go through, you take the value of your sample minus the mean, you square it. Okay, you integrate it with p of x. So going through this process, obviously what I've done here is I've expanded this out. So you get x squared minus 2 x bar x plus x bar squared. Okay, this is known as this is a constant. Okay, so this is very relatively straightforward. We don't have to worry too much about that. What I've done is I've basically separated the integral into three different integrations with each of these coefficients. Okay, like I said, this is a constant. Okay, so it's constant times by 1, because the integral of p of x is 1, so that's where this comes from. Okay, here I get 2x bar squared, and here I get x squared bar. Okay, and so the variance is known as the mean square, which is this one here, minus the mean squared. Okay, and if you take the square root of that, you get what's known as the standard deviation. Okay. And if both the mean and standard deviation are two important quantities when analysing random processes, and if the mean is 0, the standard deviation and the root mean square values are the same. Okay, and that makes sense. If your mean is 0, then obviously the square root of this is the square root of this, and so you get the standard deviation is simply your RMS value.